Okay, now going to learn about the Euclid's division lemma. Before going to learn this, we have to know that division algorithm. What is the division algorithm? Division algorithm definition is given positive integers, given two positive integers, let it be taken as a and b. There exists a pair of integers q and r, which satisfying a is equals to bq plus r, where it is r lies between 0 and b. Here this is the division algorithm. Simply we can write dividend is equals to divisor into quotient plus remainder. Up to this is the division algorithm. Okay, here a and b are any two positive integers and q or r is a pair of integers. Here q is the quotient, r is the remainder. A and b, among these two numbers, a is greater than b here. Generally here we have to take that a is greater than b. Now Euclid's division algorithm, Euclid's division lemma. Here we say that to obtain the HCF of two integers, HCF of two integers means positive integers, HCF of two positive integers. Here say we can take those are c and d. Those two positive integers, say that simply c and d, with the condition c is greater than d. With the condition c and d. Follow the steps, following the steps to find out the HCF. Follow the steps. Step 1. Here apply Euclid's division lemma. To c and d. Euclid's division lemma c and d. So we find unique pair of whole integers, whole numbers, whatever it is, whole numbers q and r, whole integers q and r, such that c is equals to d into q plus r, where r lies between 0 and d. In earlier condition, division algorithm, q and r the quotient and remainder, a and b are the integers. Here c and d are also integers, q and r are the quotient and remainders. To find HCF, this is the Euclid's division algorithm. Just we are taking the variation between these two conditions. Now after doing this, step 2. In this step 2, if r equal to 0, means remainder is 0, d is the HCF of c and d, the two numbers. D is the HCF of a final answer, that one is. If suppose if r is not equal to 0, again apply, if remainder is not equal to 0, then again apply the division lemma. Apply the division lemma. Apply the division lemma. Okay, continuation, step 3. So not 0, then go to the step 3, whatever it is. If r equal to 0, d is the HCF. So continue the process whenever r is not equal to 0. Continue the process till the remainder is 0. Now the divisor at this stage, now the divisor at this stage, now the divisor at this stage, yes, will be the required HCF. Will be required the HCF. Okay, now let's take one example to find out the Euclid's division lemma, to find out the HCF by using the Euclid's division lemma. For example, two numbers 100 and 60, or 60 and 100, which is the maximum is taken as a dividend and the smaller one is taken as a divisor. To find out the HCF, find the HCF of 160 using Euclid's division lemma. Euclid's division lemma. Okay, 100 is the maximum is taken as 100 is greater than 60. So this is taken as A, this is taken as B. We know that the condition A is equals to C D. You know that condition, C is equals to DQ plus R, where R lies between 0 and D. With this condition, C is 100. That see in the 60 table, 100 where do we get? 61 is 60. Remainder is 40 left. Okay, now 100 is divided with the 60. In 60 table, 61 is 60 plus remainder is 40. Now consider the division of 60 with the remainder 40. Now consider the division 60. Now consider the division 60 with the 40 in the above equation and apply the division algorithm again. In 40th table, 60 you will get 41 is 40. Remainder is 20. Now again, now consider the division of 40 with the remainder 20 in the equation and apply the same division algorithm. 40 becomes the dividend and 20 becomes the divisor. 20th table, 22 is 40. Now we got the remainder 0. So whenever the remainder is 0, the step 3 goes to divisor becomes HCF. Therefore 20 is the divisor here in this equation. 20 is the divisor, this is remainder is 0, 20 is the HCF. HCF of 100 and 60. Like this we have to do.